Hello and welcome back to AI Forward 2021. We're so excited to have you here. I'm really excited for this upcoming talk. It is going to focus on how AI impacts the telecom industry. Give a big, warm virtual welcome to Lucio and Tree. Welcome to the virtual stage.
Thank you, Daniel.
I'll be here if you need.
Let me share my screen. Thank you, Daniel. It's great to be at AI 421. How has AI changed telco forever? And what does AI for telco industry even mean? Today, this presentation will see how AI has and is being applied to solve the challenges facing telco industry now with real customer use cases. Hello, everyone. My name is Lucio Piccoli. I'm the CEO and co-founder of SiteSee. SiteSee is a deep tech startup based in Brisbane, Australia. This presentation will be in two parts. Part one with myself, followed by Huynh from LeBlanc, detailing his real world experiences of using AI digital twin in the telco industry. But first, let me introduce you to a huge problem facing my telco customers with the mobile telco industry right now. There are millions of telco infrastructure assets in the field that are suffering from poor decision making each year. These cell towers, you might see them on top of buildings or standing in fields, just like this one here. And these poor decisions are costing owners billions of dollars each year in unnecessary audits, inspections, maintenance, and importantly, lost revenue. Now, why is this happening in 2021? Well, it may surprise you that most owners and operators of cell towers have very little confidence in what is on their tower. The reality is that corporate ERP data is either out of date, incorrect, and sometimes it's just missing. These issues have become urgent due to the global rollout of 5G. And think about it, before you can upgrade from a 4G site to a 5G site, you must understand what's on the existing site. And this is not easy, as a cell tower can be anywhere from 25 to 70 meters in height with 10 to 80 pieces of equipment. And there are literally millions of these in the world. SiteSee solves this by creating the world's most powerful AI digital twin. We're going to talk about what we mean by that now. So that we combine drones, reality modeling, and AI to create the world's first AI digital twin. We identify each antenna, microwave dish, non-emitting piece of equipment on the tower. And this is all done using machine learning to automatically categorize each piece of equipment, its position, and its rotation in 3D. And this will produce the ultimate as-built report. This as-built report is a point of truth of what is on the tower, leading to identification of lost revenue and discovering more revenue potentials. And there's a lot more use cases that we'll be following up with Tree very soon. And remember, this has all been done without the tower being climbed. The key USP here is scale out. This type of AI automation now allows for portfolio-wide scale out, with typical cell tower portfolios ranging from 20,000 to 150,000 towers. There is simply no other technology that can match this type of AI automation. And now it's time to really see how the real world application of using the AI digital twin in the telco. So for this, I'm going to be handing over to Tree from LeBlanc. Tree, over to you.
Thanks, Lucio. Hi, everyone. My name is Tree. I'm the CEO of LeBlanc. I'm actually looking really forward to presenting our case studies today with everyone today. LeBlanc's been around internationally for almost 60 years, designing and manufacturing towers. We've manufactured guide masts, monopoles, and all types of freestanding towers, ranging from shifterized to rapid deployment solutions across the globe. So we embarked on Project Takeo, site survey and engineering services on telco structures. let's quickly go and understand firstly the why. So you can see here, we've got some photos of a tower where the rust has actually delaminated the steel, turning into essentially waffle paper. We had customers replacing their structures before their end of life. Build costs are continually rising, and it's an expensive process. Up until now, inspection relies on tower workers, firstly climbing these structures. We have safety issues. We have some sites requiring to turn the services off. And then you've got the issues of thousands and thousands of bolts to actually review. To solve this problem, we embarked on Project Takeo. So we delivered through AI digital twins, a platform for asset owners and M&Os to actually go through the process of being able to analyze data. We already have implemented this to 2 major infrastructure owners in Australia. Now let's go through the process to understand what this project is. So phase 1 is the capture process. We use UAVs to capture the structure itself. We have ground control points for referencing to get the accuracy we need. We then turn this into a digital twin. At this point in time, it's just a viewer, 3D viewer, photos, measuring tool. And this is where it gets really exciting. Through machine learning and automation, we then create an AI digital twin where we can now identify equipment. We can do as-built, as survey data, comparison reports of what we believe what was there versus what is actually there, rust detection, bolt anomaly, EME, and AI boost. Once we have all that data, we can now use as survey data to do engineering based on real data sets. We can do certified EME reports in a 3D model. And in fact, we did the world's first certified 3D EME live model. Importantly, structural integrity review. We can actually analyze the structure. We can review equipment, mount installations. We can assess the bolt holes and the rust. We can review foundations and also do safety hazards and risks on the site itself. So what does that give us? It allows us to do asset auditing, risk management, smart maintenance programs, meeting compliance and obligations, and change detection, which ultimately leads to asset life extension, importantly. Let's go back to see how this was made possible. So through as-builts, we can view the actual details of the structure itself. Here we've got a monopole. Here we're inspecting a post-installation review and seeing the microwave impact on the ladder. As you can see here, the ladder and the microwave dish is quite close. Let's go through and review the process. So in design stage, yep, dish F there. There's a clear access space for the ladder. Okay, that's a bit odd. Let's go through the signed as-built drawings. So there again, we can see the dish. It still has a bit of room in front of the ladder. And let's go drill through the as survey data. So as you can see here, the dish is definitely in front of the ladder. And you can see also through our measuring tools that the dish space between the ladder and the microwave itself is 0.49 meters. Now we go through some rust detection. So you can see here on the layers, the purple is actually AI rust detection points, and it's lit up like a Christmas tree. And using the model, we can still actually select on those rust points and actually detail in the model the photo set, which it relies on. So here you can see the rectangular in yellow there, showing the actual AI detection points. And we use this data to review and assess the level of rust. Let's look at bolt anomaly. As we mentioned earlier, we've got thousands and thousands of bolts on a structure. To determine where a bolt is or isn't missing or not, it's an impossible task. As we can see here, AI again has detected a bolt missing on a crucial member here on this splice plate diagonal connection. So that's what Takeo is. It's all those elements to create a core which is empowered by AI, and it wouldn't be possible without AI in this process. Thanks, Lucio.
Thank you, Tree. That Takeo project is a real showcase for AI in the telco industry, and it seems to be delivering real value to both you and your customers. Well done. Look, for me, that standout was both the way the AI detected the missing bolt. Now that just looks like it's a real case for AI. But before we get onto that, did you face any real challenges during the project? And if you so, what were they like, and how did you overcome them?
I think our biggest problem was capture. We had weather events during the program. We had floods. You have variances in overcast days, sunny days, and ultimately the sites that we are surveying and where Australia is located, the sites are extremely far and mobilisation costs are extremely high. So we didn't want to do any recaptures if possible. We reached out to you, Lucio, and you delivered, and again through AI. You can see here on the left here, that was a reconstruction without AI boost. It was unusable data where we got no definition, no cables, and ultimately poor accuracy. And here we can see here in the same data set without a refly, we can get exactly what we need. We've got images of the cables, we've got edges on the actual equipment, and we can actually get the data set required for our engineering analysis works.
Absolutely, and that is a really unexpected benefit for AI. Sometimes it just helps humans become better at what they do. So, as I mentioned, I really was impressed with that bolt hole detector and the missing bolt. I mean, that was a standout for me. But what was the standout success of the Takeo program for you? And just sort of talk around that.
Yeah, I think the success for us was being able to get and demonstrating what as surveyed data was. To date, we've got the terminology of as built, and we've challenged that word. With Project Takeo, we demonstrated to the client what was actually on site, what equipment heights was installed, at what height, what bearing, and with extreme accuracy. Data sets that were never ever available before. You go back to as-built where early in the days people would use tape measures. We've got laser tapes, but how do you record that data set? Here we've actually managed to give our clients a point of truth. There's no relying on a person taking a photo. It relies on the actual AI platform to deliver the point of truth. And I think what was most interesting for the clients, and I guess from an engineering house, disturbing for us, was how much variance there was. We had equipment variances over, on average, around 1 meter, where sometimes the equipment was installed higher, sometimes the equipment was installed lower. And structurally, the equipment's installed higher and what infrastructure is now, which is extremely not overloaded, but extremely populated. It is critical because we can have structure failures because of the fact that the data set isn't correct.
I get that. Yeah, I get it. And so the real message there is that the AI, in conjunction with the digital twin, is giving you, the engineering team, the ability to make better decisions for your customers. Yeah, I mean, is that the sort of takeaway?
Yeah, definitely. And I think that what it does give us is actually confidence. You mentioned that earlier. We now have confidence as both the manufacturer and the engineers that we know what we're actually designing and certifying. And that gives us also confidence when we actually do 5G upgrades, placements of equipment and so forth, to make sure that what is there is actually there.
Absolutely. And you mentioned the 5G upgrade. That rollout program is just, it's only getting more and more intense, isn't it? So looking forward, Tree, where do you and your customer, where do you guys see AI impacting your your world and your ecosystem, and what are you looking forward for new features, new functionality, and what do you think they're going to look like for both you and your customer?
I mean, 2020, 2021 has been probably the most challenging time for, I guess, ourselves globally with COVID-19. And what COVID-19 has given us is an understanding and an appreciation of what life relies on. I mean, we're all working from home. Mobilizing to site to do site surveys is significantly more challenging these days. Switching off a service or having a service going down to do upgrades. You know, if you don't get thousands of phone calls, you'll be surprised. So that's the challenge as of today. And we need to find ways of being able to, we've got an AI model. We need to find ways that then we can actually do designs. We can do predictive engineering using AI, EME simulations to speed up build.
Well, Tree, have I got something for you? So AI is going to deliver that. So look, let me share with you what we've been working on. And this is something that I think should answer and give you and your customers what they need. So maybe you can talk through, Tree, what we're looking here from your perspective. So this
Sure.
is our platform as you sort of look at it now.
Yeah, so we've got our AI digital twin. You can see the standard definitions here. You've got a load table, which indicates the existing structure properties of the structure and foundation and rotation. We've got our EME there, and we've got our selection of equipment.
Sorry, Tree. And that's the existing AI digital twin that you've been using for quite a while, right?
Yep.
So what else would you like to do now?
As I said earlier, I mean, really being able to add new equipment in simulation so we can then actually design if the equipment can fit, if we can actually see if we get the separation requirements, line of sight, ensure that the mounting equipment can actually attach to the equipment itself, and then also making some decisions around, is the structure capable or not? A lot of the problems that clients face going on to a co-location or their own assets is the time it takes between doing a proposal and getting a design back, because the problem is the equipment itself and the structure are quite heavily loaded, and what impacts that is that the 5G upgrade or any additional works may actually create overloading. And then you have a situation and simulations around at what heights or what equipment can I use to bring the loads down to avoid upgrades. This will allow us to actually make decisions at the right time rather than later on, which is going to actually have huge impacts in the speed of rolling 5G.
I think you're right. I think this is where the real combination of AI and the digital twin to really allow the human to do their job better, right? So AI is not at the moment going to redesign the entire tower, but it does do the heavy lift to allow the humans to do their job just that little bit better and a little bit faster. Is that a fair?
Yeah, I agree.
assessment?
Yeah, I agree, Lucio. We're not going to replace engineers. What this actually does is speed up the process of the engineering and the certification. It's getting rid of what the back and forth, the loss of time that's required to do that. And it's actually then giving the data set required for our engineers or for any engineers to actually do what it's important as actually designing, certifying, going through the finite details of the actual analysis rather than playing with RF designs. Hey, let's let the RF engineers and the TX engineers do that design work and the grunt work up front. Absolutely.
Well, look, Tree, I think that we'll wrap it up here. I think this is a really good demonstration of how you and your company are delivering to the telco industry right now the benefits of AI. So congratulations and thank you.
Thanks, Lucio. It was appreciated to be able to show that, and yeah, exciting times ahead.
All right, a big virtual round of applause for both of these presenters. I'm sure the crowd is going wild virtually. And everybody else, go do some networking, and I'll catch you at the next one. Take it easy.